Dear students, my name is Prasannanjaneyulu. I am Associate Professor of Mathematics in CMR College of Engineering Technology, Hyderabad. Okay, now I am going to discuss about some problems related to vector identities. I cannot say it is related to vector identities. Okay, writing it in the form of summations and doing it. Okay, so before we discuss that, I am going to explain what is a general R bar vector and how we have to represent them. And it will be useful for our problems. Okay, in general, R bar equals to xi bar plus yj bar plus zk bar. Okay, its magnitude, okay, modulus of R bar or norm of R bar is going to represent it as a small r. So magnitude of a small r is equal to square root of x square plus y square plus z square. Then with this, what I am going to write is that implies what is r square? X square plus y square plus z square. How we can write this x square plus y square plus z square summation x square, and same manner r bar also can be written as a summation xi bar, which is equals to r bar. So these are the notations we may use in our problems. Okay, wherever summation xi bar is there, I am going to write r bar. Wherever summation x square is there, I am going to write as a r square. Then now I am going to take this as equation number 1. I am going to check equation 1 is r bar, sorry, r is equals to square root of x square plus y square plus z square. R is a function in terms of 3 variables x, y, z. So we can take the partial differentiation of r with respect to x, with respect to y, with respect to z. So what I am going to do is partial differentiate 1 with respect to x on both sides. Then what it's going to become? Differentiation of r square is 2r into dou r by dou x equals to differentiation of x square is 2x with respect to x. Differentiation of y square with respect to x partially is 0, and differentiation of z square partially with respect to x is 0. Then what it is going to become? 2r into dou r by dou x equals to 2x. Then here 2 and 2 gets cancelled. Then it is going to get dou r by dou x equals to x by r. This will be helpful for our problems. Same manner, if we do partial differentiation with respect to x, with respect to y, then we get dou r by dou y equals to y by r. This is also helpful for us. And same manner, partial differentiate with respect to z, which one? Equation 1 only. Then we are going to get dou r by dou z equals to z by r. Okay, so these are the things are helpful for our problems. So I'm going to take the first proof, or they will give, these are for short answer question or 2 marks or 3 marks bits. So here the first one is prove that del of r power n equals to n into r power n minus 2 into r bar. This we have to prove. For proving this, I am going to, in all the proofs, it is mandatory. It is not mandatory to write all these things, but it is mandatory to remember all these cases. Okay, in all the problems, instead of discussing in the problem, I am going to, I explained here in a simple manner. Okay, now I am going to take del of r bar, sorry, r power n. What is r? R is a scalar in terms of xyz. R power n is also a scalar in terms of xyz. Okay, so assume this is as phi, del phi. What is del phi? I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. So how we can write it is in the form of summation. Summation I bar into dou by dou x of r power n. But summation I bar into, what is the partial differentiation of r power n with respect to, what is the partial differentiation of r power n with respect to x? It's going to become as n into r power n minus 1 into derivative of r with respect to x partially, dou r by dou x. This we got. Now summation n into I bar into r power n minus 1 into, what is dou r by dou x? Is nothing but, just now we discussed, dou r by dou x is x by r. Then the next step, I'll write I bar into n into r power n minus 1 is there and denominator r is there. If we take the denominator r also to numerator, it will get r power minus 1. So r power n minus 1 is n minus 2 into x. Here n into r power n minus 2 is a constant because there is no effect of the summation on this. That means if you expand the summation, only these two things are going to become changing. Better I'll write like this, n into r power n minus 2 into x into I bar. X into I bar. Now I will write this n into r power n minus 2 outside of the summation. Then summation xi bar. As we know that summation of xi bar is nothing but r bar, because xi bar plus yj bar plus zk bar is the general form of r bar vector. So it is going to become n into r power n minus 2 into r bar, which is the value of del of r power n. Hence proved. Okay, so going to the next property, the second property second problem. Prove that del of f of r equals to, we have to prove that del of f of r equals to f dash of r by r into r bar. And here they are giving r bar equals to xi bar plus yj bar plus zk bar. Even if they give r bar equals to xi bar plus yj bar plus zk bar, or they are not giving, means then blindly we are going to take the same. Okay, so now here the proof is similar to the above. Here del of f of r, because already I discussed earlier what is dou r by dou x, r by dou y, dou r by dou z, and r bar. So I'm not discussing all these things here again. So f of r is a scalar function in terms of xyz. Del phi form. What is the del phi? Can be written as in the form of summation. Summation I bar into dou by dou x of phi. Nothing but f of r. Okay. So summation I bar into, what is the differentiation of f of r partially with respect to x? It is f dash of r into, again f of r is in terms of r variable, so dou r by dou x. Summation I bar into f dash of r into, dou r by dou x is nothing but x by r. Dou r by dou x is x by r. Then here summation I bar into x into f dash of r by r. If you observe, there is no effect of summation on f dash of r by r. So we can treat this as a constant bringing outside of the summation. Not constant, it is in functions of x, y, z, but there is no effect of the summation on this. So summation x I bar. So we know that summation xi bar is nothing but r bar. So finally f dash of r by r into r bar is the proof of del of f of r. So this is the thing we need to prove, hence proved. Next one, prove that r power n into r bar is a solenoidal vector if n is equals to -3. This we have to prove. Yeah. First of all, the solenoidal vector. When we can say a vector f bar is said to be a solenoidal vector is if divergent of f bar equals to 0. If divergent of f bar equals to 0, then f bar is called a solenoidal. Okay. This is the definition of a solenoidal. Now, for proving the given vector is a solenoidal, so we have to first find a divergent of r power n into r bar. So for finding the divergent of r power n into r bar, first I am going to take r bar. Let r bar equals to, what is r bar? xi bar plus yj bar plus zk bar, right? So it can be written as in terms of summation of r into x into I bar. Okay, that is not required. Now, multiplying r bar with r power n. R power n is a scalar function in terms of xyz. Multiply with r power n on both sides. Then r power n into r bar equals to, multiply all the terms with r power n. So x into r power n into I bar plus y into r power n into j bar plus z into r power n into k bar. So now r bar is a vector, r bar into r power n is also a vector. So how it looks like? It looks like okay, a vector in terms of x h bar. So I'm going to take h bar equals to h1 I bar plus h2 j bar plus h3 k bar. Then what is the divergent of h bar? Dou h1 by dou x plus dou h2 by dou y plus dou h3 by dou z. Okay, so for proving the given vector r power n into r bar is a solenoidal, we have to find divergent of r power n into r bar. So instead of our vector h bar in the example, we are having r power n into r bar. So take divergent of r power n into r bar. So what is r power n into r bar? In our example, h bar. So what is the divergent of h bar formula? Dou by dou x of h1. h1 is nothing but I bar quotient. X into r power n plus dou by dou y of h2. h2 is the j bar quotient. Y into r power n plus dou by dou z of h3. h3 is the coefficient of k bar. So what is the k bar coefficient? Z into r power n, right? Then that implies divergent of r power n into r bar equal to, then first term x and r power n. R power n is also in terms of x variables. So partial differentiation of x into r power n with respect to x is nothing but partial differentiation of uv. So what is that? U into v dash x into r power n derivative is n into r power n minus 1 into dou r by dou x is the first term plus u dash is 1 into v. V is nothing but r power n plus same manner. What is the second term is going to get? Second term derivative u into v dash. V dash is n into r power n minus 1 into dou r by dou y in plus u dash into v plus third term. The third term also in the same manner u into v dash, because z into r power n, both are in terms of z variables. So we have to partial differentiate with respect to z. Differentiation of uv only. U into v dash. What is v dash? N into r power n minus 1 into dou r by dou z plus differentiation of z is 1 into r power n. Then what I'm going to do is here, I'm going to take all the first terms at a stretch, and same manner all the second terms at a stretch. Then what are the first terms can be written as n into x into r power n minus 1 into dou r by dou x is x by r plus second term. That means first term in the second term, that is a single underlined one, n into y into r power n minus 1 into dou r by dou y is y by r plus the first term in the third term. Okay, so which are underlined with one line. So n into z into r power n minus 1 into dou r by dou z is z by r plus, if you observe the two underlined things, terms, r power n, r power n, r power n, how many times? 3 times. So 3 into r power n. Then I'm going to write the final, last but one step here, n into x square into r power n minus 2 plus n into y square into r power n minus 2 plus n into z square into r power n minus 2 plus 3 times of r power n. But if you observe the first three terms, what can be taken common? N into r power n minus 2 common. Then that implies divergent of r power n into r bar is equals to n into r power n minus 2 if we take common. What is left over in the first term? Check it. X square, second term y square, third term z square. So what I can write, x square plus y square plus z square as r square. That is the next step. Okay, x square plus y square plus z square plus 3 times of r power n, then n into r power n minus 2 into x square plus y square plus z square is r square plus 3 into r power n, which is equals to n into r power n minus 2 plus 2 is n plus 3 into r power n. Then finally n plus 3 into r power n is the divergent of r power n into r bar. Okay, when we can say this will be solenoidal. Okay, by definition we can say r power n into r bar is solenoidal if, what is the definition? Divergent of r power n into r bar equals to 0. And it is possible if n plus 3 into r power n equals to 0. That implies n plus 3 equals to 0, but r power n is not equals to 0. That implies n is equals to minus 3. So our given vector r power n into r bar is solenoidal if n equals to minus 3. Hence proved. R power n into r bar is solenoidal if n equals to minus 3. Okay, so like this you are going to have few more proofs we will discuss in the next video or next lecture.